Alright, we're going to take a look at how current will flow through parallel circuits and what the equivalent resistance is in a parallel circuit. Now when we have current leave the battery, remember it leaves the positive and enters from the negative for conventional current, so it's going to flow up here. It's going to hit this point and then it can either go across this resistor or it can travel up and around to this resistor. Now let's pretend that this is a 6-volt battery and that this resistor right here is 3 ohms of resistance and this one is 6 ohms of resistance. So what we need to do is figure out how much resistance, if I was to take both of these resistors and turn it into one, what that would actually look like. So the rules for adding resistors in parallel is we have to add them with the reciprocals and then take the reciprocal of the answer. What that means is I would take 1/6 plus 1/3, and then we have to get that into the common form of 1/6 plus 2/6 equals 3/6. And we take the reciprocal of this value right here, and that will be 2 ohms of resistance. So what that is saying is if I was to take this circuit and replace the 6 ohm resistor and the 3 ohm resistor, a 2 ohm resistor would act the exact same way and allow the same amount of current to actually flow through this circuit right here. To figure out the amount of current that flows through it, what we do is remember that 6 volts travels across this one, and then it doesn't see this one, and it'll travel 6 volts across this. So we're going to use Ohm's law from earlier, which is V equals IR. And we are going to try to figure out how much current flows through the 3 ohm resistor and the 6 ohm resistor. So let's do the 3 ohm resistor first. So I have 6 volts, I have 3 ohms, and that would equal 2 amps of current. So that means that 2 amps of current are going to flow through this branch right here. And this branch up here, we got to figure out how much is going to go there. So I have 6 divided by 6, so 6 volts divided by my 6 ohms. And that is going to be 1 amp. So this branch gets 2, this branch gets 1, and I add those 2 branches and they're going to equal 3 amps total. Now if I come back over here on the right hand side and I take a look at this 2 ohm resistor, so we replace this, we redraw it, it looks something like this. And I put my 2 ohms right there, a 6-volt battery right there. If I'm following Ohm's law again, V equals IR, and I do my 6 divided by 2, I get my 3 amps. So that's the way to double check your work. So the total current when I replace my resistors needs to add up to the sum of both branches. So I have 3 amps that go in right here, 2 amps go this way, 1 amp goes up here, and then they come back together right here, and then they go back to the battery as 3 amps. So there's no loss of current throughout the whole circuit. Hopefully this helped.